Hi, this is part 1 on my build for my good indicator holder. We'll see the process of how I make those two clamp for 12 and 16 millimeter shaft. So I'm starting the track DPM using H3 control. I went to the stock rack, get my A2, and this is a pretty large bar for my little vertical Benza. Had to support it at the end, and I used this vise as a counterweight so the table wasn't tilting, and cutting the stock I need for 3 sets of clamp. So I'm squaring up this stock on every 6 side. And the end is very important because I use it as a stop, as a reference datum. And now I'm going back to the saw and cutting in 2 for the 2 sides. So both clamp have the same thickness, so I'm just finishing the thickness of the clamp now. Now I'm using the edge finder to find the distance between the 2 stock for my two datum, and I'm gonna use this offset for all machining operation from both sides. So now I'm just drilling and chamfering and finishing the diameter for the 16 and 12 millimeter hole. And here you can see the last hour of this drill chuck that I'm destroying, trying to use the 16 millimeter reamer. So that's why I changed for the boring head to finish those holes. And I got them on size, just a little bit under, so I still have material for final lapping when they come back from heat treat. Using the chunk hydraulic tendel with the 8mm carbide, I'm machining the shape, and I'm using the same stop and the same incremental repeat function as when I did the bore for the 16 and 12 millimeter. The depth of the part is exactly on size, and now I use the setup to chamfer on this setup since it was easy. And now I'm parting up the part on the vertical Benza, which is pretty handy. It gives you a lot of material to hold on in the vise, so it's a lot more rigid. And when you're done, you end up with a lot of material still, very little to machine on the part you finish, and the leftover stock is square on 5 sides, so it's really easy to reuse. So you see how much material I still have to machine out. That was less than a millimeter, so very quick way to do it. And now I'm taking each single part to rough out the material on this radius. I have to flip the part upside down, so I have a bit of a clamping force to keep the part in the vise, because now it's starting to get hard to hold on. And now I'm switching to this setup when I can use the full length of the 16 millimeter carbide end mill. That was the longest end mill I had to be able to do this, and I'm doing it this way because I want a single cut, a perfect blend on this radius, so not too much filing, and all the rough material mean that I got pretty low cutting force, and I can get away with such a setup. If I had to taking on the end of the vise and do it, or try to rough all this material as so much chatter that the part will fly out the vise. Now I'm using the large radius on each part, which is the same, using a 1, 2, 3 block for a new datum, and this new datum will be used for every single operation that are coming. So here I'm chamfering the back, and then I'll flip the part 90 degree, I'll chamfer the top, and so on and so on. Now I'm using the new drill chuck to make the contour bore for the 6mm socketed screw that's gonna clamp on the shaft. So that's why I build this setup, so all this manipulation get very fast and very quick. And now I'm using a broken 45 degree end mill to be able to chamfer this part. That was the only one that can reach there. Drilling, chamfering for the 6mm C-bore on both sides. Here I got all the part, and on the other side still the same datum, still the same setup, didn't change anything. And splitting the clamp, didn't use a slitting saw. It's faster on the vertical bend saw, and it's very precise, and the cut quality is very good. So a bit more hand finish and those portraits are done.